Okay. Hello everyone, and welcome to this second session of the CCNA course. Okay. Now today what we are going to basically do is continue with the first topic of the CCNA course. Okay. Now before we continue, just a mention out here that your computer should have Packet Tracer version 6 running on it, so that in the future when I give you some labs, those labs would be based on Packet Tracer version 6. Okay, so it would be easier for you to do those labs. Okay, so that's something that you have to take care of. See to it that you have Packet Tracer version 6 running on your machine. Okay. Now to start off with, today what we are going to focus upon is this particular topic that you see on the screen, that is building a simple network. Okay, so in this topic we are going to look at the basics of networking. Okay, so we are going to understand what is a network, what are the components that build up a network, and many other certain topics related to networking. Okay, so that's what we are going to do first of all. Okay. Now under this, the first section that we are going to deal with is exploring the functions of networking. That's what we are going to look at. Okay, exploring the functions of networking. Okay, so when I talk about this particular topic here, okay, let's try to understand or discuss about what is a network. Okay, a network, okay, when I talk about a network, there can be different types of network, but what we are basically dealing with is a computer network, or a network that is built based upon networking devices like PCs or desktops or laptops or smartphones or wireless devices. Okay, so it can be any of these devices, but a network typically is a group of devices or a collection of devices that communicate and share resources amongst each other. Okay, let me repeat that again. Okay, a network is a group of devices or a collection of devices that communicate or share resources amongst each other. Okay, so a network typically is used for sharing of resources or for communication purposes. Okay, now what do I mean by sharing of resources? Okay, let me give you a simple example. On one of the computers, let's say if I have a PDF document, and then if I want to share that PDF document with a user on another computer, so in that case both the computers need to talk to each other or communicate with each other. So they are going to communicate with each other through a network. Okay, so when these computers are communicating with each other, that's when I would say that I have created a network or I have formed a particular network. Okay. So whenever I talk about a network with regards to a working environment or an office environment, we would typically have the headquarters network or the corporate office. Okay, so the headquarters or the corporate office would be the central office or the major office where all the resources would be located. Okay, so it would be a network that is formed by servers or devices which would be having a lot of resources inside it. Okay, and then we'll have branch offices, which would be another building which may be in a remote location or at a particular location other than the corporate office. Now this branch office is going to access resources from the headquarters. Similarly, when I talk about home office would be typically a small network that is established, a small network of maybe a few number of computers. Okay, so that network, when it tries to access resources from the headquarters, so that could be called as a home office. And then we can have mobile users or users who are using smartphones or users who are using laptops, and then through the mobile networks they are trying to connect to the internet, and then through that when they try to access the headquarters, so then in turn they are forming a network. So bottom line is, all these four components that you see on the screen right now is basically like connected to each other via the internet. Okay, so a simplest way of defining a network would be, okay, devices should be able to talk to each other or communicate with each other, and in this particular diagram that is what these devices are able to do. Whether these devices are at the headquarters or whether this device is in the branch office or whether it's part of a small office or a home office or whether it is a mobile user device, all of these are communicating with each other via a common medium, that is the internet. Okay, so they are able to talk to each other. So that's where I have formed a network out here. Okay. Now let's talk about what are the various components, physical components that allow us to create or bring up a network. Okay. Whenever I talk about creating or setting up a network, one of the primary things that you would need is a computer. Now that computer can be a laptop or a desktop, or it can be a smartphone or any other device for that matter, but that device needs to have a network interface card or NIC. Okay, it needs to have a network interface card or a network card as we call it sometimes. Okay, now what is the usage of this network interface card or network card? The usage of this network card is to connect to other networking devices. Okay, so what is the purpose of the network interface card? It allows the PC or the laptop or the desktop to communicate or to connect to other networking devices. Like in this example, as you can see, all these 4 PCs out here, okay, via the network interface card, they are connected to switches. Okay, so the switch would be another kind of a device that you would need. Okay, so typically you would have your computers connected into a switch. Okay, now over a period of time, we are going to talk about IP networks. That is, networks that are formed based on IP addresses or Internet Protocol addresses. Okay, so if I have Internet Protocol addresses or IP addresses configured on individual computers, it might happen that these computers may fall in a different group of an IP network, and these computers out here may fall into a different group of an IP network. So in that case, if these computers need to, or if these 2 groups need to communicate with each other, in turn we need to have a router. Okay, so as you see here, this is one group of computer which is connected to this switch here. This is another group of computers which is connected to this switch here, and these switches in turn are connected to the router. So effectively now this PC out here is able to communicate with this PC in another group. Okay, but whenever I talk about that, how do I configure or how do I connect this network interface card or NIC with a switch, or how do I connect this switch to the router? For connecting those, we would need to have a network media, that is a cable. Okay, so we need to have a network cable. Now those network cables, at each end of the network cable, we need to have these kind of connectors. So we'll be talking more about this as we go along, but for the network cable to be used, or for connecting these network cables to the network interface card, or connecting one end to the switch, or connecting one end to a router, we need to have the cables, and at the end of the cables we need to put up these kind of RJ45 connectors. So bottom line is, we need to have PCs, we need to have network cables, we need to have network interface cards. Those cables need to have RJ45 connectors, we need to have switches, and then we need to have routers. Okay, so these are all the components that make up a network. Now even at home, like right now all of you are connected to the internet at this point, right? And through the internet you are connected on this via this online meeting. But when you're doing that, okay, your machine, like be it a laptop or be it your desktop, your machine may be connected wirelessly or through a wired network. Okay, so when it comes to connecting wirelessly or connecting to the wired network, you would typically have a network interface card. So if it is connected wirelessly, so in that case the network interface card which we are talking about is a wireless network interface card. But if you are connected via a wire, then in that case we are talking about a wired network interface card, which is in turn going into a switch. Now if you are connected wirelessly, in that case you are connecting to a wireless access point. That wireless access point would be an equivalent to the switch. Now in front of the switch, or at the other side of the switch, or other side of the wireless access point, you may have your broadband or your internet router, and then in turn at the other end of the internet router you would have the cable or the connection coming in which provides you with internet connectivity. So bottom line is, each and every network, be it within an office or be it within a home network or a home environment, you would need to have these kind of components out here. Okay. Now another important thing when we talk about networks is, like throughout this course we'll be trying to understand various kinds of network diagrams. and it is very important for us to understand what is or how to read a network diagram. Okay, so whenever we talk about a network diagram, let's talk about an example of this particular thing here. Okay, so whenever you see a cloud typically represents that it is some sort of remote connection. That remote connection can be typically the internet, or over a period of time we are also going to talk about something known as a WAN. Okay, so in here this cloud, this gray colored cloud which you see here, represents the lab internet or internet connection that is connecting this lab. Okay, now you would also find these kind of lines. Okay, so these red colored lines that you see here, straight lines, they normally represent an Ethernet connection. Okay, Ethernet, we'll be again talking about Ethernet as we go along in this particular topic, but then for now just understand this: whenever we are making use of these kind of cables, okay, network cables, those are representing Ethernet cables, and those connections are represented out here. Okay, and in the diagram you would also find these kind of names out here like FA0/1. This FA0/1 is nothing but the interface ID of this router. Similarly, do you see these black lines here? These black lines are representing console 0. Okay, now it is this console 0 or this console cable through which you can configure the router. Okay, now between the routers you would also typically find these kind of crooked lines. These crooked lines which you see out here, which are red in color, they are typically the serial connections. These serial connections are basically used to connect to the WAN. Okay, now as you see out here, this router has a connection going into the switch. That is typically an Ethernet cable. Then we have this server out here. This block which you see out here is the server, and that is typically a TFTP server. We'll be also talking about what is a TFTP server as we go along. But this TFTP server is again connected to the switch via an Ethernet cable, and it is connected on FA0/12. That is the interface ID of the switch. Then we have this particular machine out here, that is a normal computer which is acting as a DHCP client. Now what is a DHCP client? Basically it is a machine which is going to receive an IP address from a DHCP server that is also connected to the switch. Now if you find this kind of a connection, that is nothing but a VPN connection. If you find this kind of a dotted line, that means we are talking about an SSH connection. Okay, and this router which you see out here, which is typically connected or shown in gray, that is typically the console router or the access router. That is what we call it as. And then we could have laptops or desktops, which like this is a representation of a laptop, which is representing a remote class. Okay, so bottom line is, whenever we talk about a lab devices, they would be shown in blue. Okay, these other devices would be shown as gray, and then you would have these other computers like DHCP client or remote class laptop or server or main router or backbone router. Okay, these would be other kind of devices which you would see typically in a network diagram. Now do not worry if you are not able to understand this diagram immediately right now, but we'll talk about it more as we go along in this particular topic here or in this particular course here. Okay. Now whenever we talk about functions and benefits of a network, as I told you before, one of the primary functions of a network is to share resources. Okay, now what can be the resources? Resources typically can be files or folders. Okay, it can also be printers. Okay, I hope you know what is a printer. Printer is a device which will allow you to print some documents or print certain text onto a document. Okay, you can also have devices which will provide you with voice over IP or phones. Okay, phones can also be connected into switches or these kind of devices. Now what is the purpose of these phones? It will allow you to make calls, phone calls or audio calls, right? So bottom line is, okay, there can also be devices like network storage devices. What are these? These are nothing but like hard drives. Okay, hard drives which have an IP address on it, and you can access these hard drives from over the network. What do these hard drives contain? These hard drives contain data which can be accessed over the network. So bottom line is, you can have data and applications, various resources like printers, network storage devices, or you can also have backup devices, which are again storage devices into which you store the various kinds of backups. Okay, so bottom line is whenever we talk about a network allows you to share resources, and it will allow you to store and manage the various kinds of resources. Okay. Now, whenever we talk about network, for establishing this network or for sharing the resources, we also need to have various kinds of applications. So when we talk about network user application, one of the most common network user application would be email. Like typically for checking out your email, you may make use of Outlook, or you may make use of Thunderbird that comes in from Mozilla. Okay, you may make use of Fedora client or Eudora client. Okay, so when we talk about these kind of clients, these are email clients through which you can check your emails. You can also have POP3 clients or Yahoo or Gmail. All these are email client applications. Okay, so that could be typically used for checking out your email or for sending emails. Then you would have web browsers like Internet Explorer, Firefox, or Google Chrome, or many other different examples which would allow you to browse the internet. Okay. Then you would have instant messaging applications like Yahoo Messenger or Microsoft MSN Messenger, or you may have Gtalk or Google Plus Messenger, Google Plus Hangout as we call it. Okay, Facebook Messenger. All these are instant messaging applications. Then for collaboration purposes, like the way we are doing it, we are conducting a meeting on top of WebEx, right? So WebEx can be one example of collaboration software, or Whiteboard, or NetMeeting, or AnyMeeting, or GoToMeeting, or MyMeeting. Okay, there are a lot of different applications available on the internet which will allow you to collaborate or conduct meetings online. So those are called as collaboration applications. And then we would have databases, which could be typically file servers like FTP servers, or it could be SQL database servers or Oracle database servers. Okay, MySQL servers. There could be a lot of examples with regards to databases as well. So all these applications that you see out here are called as network applications. Okay, so these applications need to have a network. Without a network, these applications would not work. Okay. Now, whenever we talk about impact of user applications on the network, okay, applications can be typically classified into batch applications, interactive applications, and real-time applications. Okay, so we'll elaborate on each one of them one by one. Let's first talk about batch applications. Batch applications means typically when we talk about FTP, that is file transfer protocol, or TFTP, that is trivial file transfer protocol, or inventory updates. Okay, so these kind of applications are called as batch applications. Now, what is the purpose of these batch applications? These batch applications allow you to download data or download information. Okay, like if you go to download.com, okay, there is a lot of software that are available on download.com. Okay, now download.com is a website, but similarly, if I talk about FTP servers, okay, the FTP servers would typically have a lot of files and folders inside it, and we can download all those files and folders from an FTP server. Typically, when I talk about TFTP servers are typically used to download softwares which can run on networking devices like routers or switches. Okay, but even then, when we talk about these applications, they allow you to download data or download information. So when I talk about these servers, once you set up the server, you do not need any kind of human interaction. You just need to go into your computer, connect to that server, and download the data. So in that case, bandwidth is important, but it's not critical. Even if you have a slow bandwidth or a very low bandwidth, still you can download the information. Okay, so that's the main thing about it. So when we talk about network speed, speed is important, but it's not critical. That is, even if you have a slow speed link, on that slow speed link also you can download the data. Okay, so that is what I call as a batch application. Now let's talk about interactive application. Now what do I mean by interactive application? Okay, so the best example of interactive application would be like for example bookmyshow.com. Okay, now what is this bookmyshow.com? It allows you to book movie tickets online. Okay, so that is an example of bookmyshow.com. Now this is a website popular in India, but the point is, when I talk about this website, what does it do? It queries the databases of various movie theaters, and then it provides you with a listing of all the movies that are running at various theaters, and it gives you a real-time information about which movies are available at what time and so on. Okay, so you can inquire about what are the latest movies that are running, what are the timings for the various shows. You can request for database updates as well. Okay, so in that case, typically it is a human to machine interaction. Like for example, if I talk about ATM machine from which you withdraw money. Okay, so that ATM machine also can be termed as an interactive application. Okay, you can request for your balance info, you can withdraw money, you can check your account balance, you can do a lot of stuff with regards to an ATM machine, right? So it's basically a human to machine interaction. Okay, now when it comes to human to machine interaction, since the humans are making use of these machines and they are waiting for a response, it is important that you need to have a good response time. Okay, but what I mean by good response time is, I cannot have an ATM machine or I cannot have an application through which when I request for some info, it takes approximately, like, let's say 5 to 10 minutes to give me the response, right? That is not tolerable. If I have an application which gives me a response within, let's say, 2 minutes, 2 minutes is still fine. So bottom line is, it is important that you need to have a good response time, but it's not critical. So bottom line is, response time is important when it comes to interactive application. And then we have real-time applications. Now what do I mean by real-time applications? Real-time applications as in the stock market application, or typically if you talk about applications like YouTube streaming, wherein you can watch those live cricket matches, or YouTube streams of football matches. Okay, so when I talk about these kind of websites, what do? They give you a live score of all the various sports activities that are running out there. So if that is the case, if at all that application is slow, what will happen? The sports activity might have like started and finished, and then you might get information after that. That is not tolerable, right? So latency is not possible or not tolerable. Latency means delay. Okay, so whenever I talk about real-time applications like voice over IP or video streaming, it's very important that there is no delay out there. Okay, you need to have a good amount of fast response with regards to these applications. Okay, so that's these are the various classes of applications that you might have on the network. Now, whenever I talk about setting up of a network or characteristics of a network should have a good speed. Okay, what I mean by that is, transfer of information should be quick. Okay, so that is what I should have. The cost of the network should not be too high. The cost of implementing or setting up the network should not be very high. Okay, the network should also provide you with good amount of security. What I mean by security out here is, the information that is available on the network should be shared, okay, with the appropriate users. What I mean by that is, the information should be available only to the authorized users. Okay, anyone should not be able to connect to the network and download the resources. Okay, it should be available only to the authorized users. So that is how I would think about security. The network should be always available. Okay, the network should not be completely down. It should always be available whenever I need it. It should be scalable. What I mean by scalability out here is, the number of devices that you keep on adding to the network performance should not be affected. Okay, so it should allow for the inclusion of a lot of devices. It should be reliable. What I mean by that is, the communication should be reliable. That is, whatever data I transfer through the network, okay, it should be transmitted as is. That is, the data should not be lost or the data should not go corrupt when I'm passing the data through the network. It should be reaching the destination the way it was transmitted. Okay, and network topology or the network design is also equally important for setting up a good network. Okay, so when I talk about that, whenever I talk about a network, the physical topology of the network or the physical connectivity of the network is also equally important. Okay, so when it comes to that, these circles which you see here, the blue colored circles, are nothing but the nodes. Okay, the various kinds of networking devices, and depending upon how these network devices connect to each other, we have these different types of physical topologies available. You have the bus topology, which is an old kind of a topology wherein all these devices are connected to a common central bus. Okay, now the problem with this bus topology was, if the bus goes bad, okay, let me just draw it and show it to you. If this central line or this backbone goes bad, okay, like let me just highlight it for you. Okay, so if this backbone, if it goes bad, let's say, what will happen? In that case, the entire communication of all these nodes is lost. Okay, so this central common line that you see here, or the bus, is the core component of this particular topology. Then we also had another kind of a topology known as ring topology. Now, when I talk about ring topology, it was typically used in an older kind of a network implementation known as token ring. Okay, wherein all these nodes connected to each other in a circular fashion. So even if this ring failed, or one of the links out here in the ring failed, okay, the communication was possible in another direction. Okay, so even if it fails in one direction, the communication would be successful in the other direction. So that was one advantage of the ring topology. But whenever I talk about the bus topology and the ring topology, these are old ways of communication with regards to network. The latest way of communication with regards to network is the star topology. What we have in the case of star topology is, we have the central device which would be typically like a switch. Okay, and on this switch we would plug in or insert all the other devices. Like typically at home also, if you have like various devices, what you would typically do is you would run a cable from each of your device to a switch. So that switch is acting like a central device, and then all the other devices are connected to that central switch. Okay, so that kind of a topology is what is called as a star topology. So out here, even if one of the links goes bad, the entire communication is not stopped. The communication with regards to that particular node is affected, but otherwise all the other devices are able to communicate with each other. Okay, so that is why the star topology is the latest kind of physical topology that is used nowadays. Okay, so we are not going to talk much about bus topology and ring. We are going to mainly focus on star topology. Okay. So as you notice here, that's the logical topology. So whenever we talk about topology of a network, there are two types of topologies which you need to understand. The topology which is based on the physical connectivity of the devices is called as the physical topology. So what does a physical topology tell you? The physical topology talks about how the devices are connected to each other. Okay, how the devices are plugged in or connected to each other. That is what is defined by the physical topology. Okay, and the logical topology basically talks about how the devices are communicating with each other. Okay, so it's not really bothered about how they are physically connected. It's more bothered about how the devices are communicating with each other. Like for example, out here, E and F, if you see the computer E and computer F, they are connected via this line. But how is this line created? This line would be practically created or physically created using a switch, but that is not shown out here. Okay, so that is not shown out here. In turn, they are all connected to this hub. So bottom line is, the computers E and F are connected to each other by some means. That would not be shown in a logical topology. The logical topology will only talk about how the devices are communicating with each other. Okay, the physical connectivity of all those devices would be shown in the physical topology. You understand the difference between physical and logical topology? Okay. So in between, whenever I ask you questions, please be sure to either respond back, or maybe you can put up your responses in the chat window. Okay. So at this point, are you clear with a physical topology and a logical topology of a network? Okay. So going ahead, so as I mentioned before, Bus topology, when I talk about it, if at all I send some signal across this bus, it is going to be received on each and every individual node connected to that bus. Okay, so that's the main thing about bus topology. So that's the reason if something goes bad with this regards to the bus, the entire communication is affected. Okay, so that's what happens in a bus topology. But remember again, bus topology is not at all used nowadays. Okay, whenever I talk about star topology, you would have the central device, and to this central device all the other devices are connected to it. Okay, so the transmission is through typically a central point. What I mean by that is, if this computer out here, like let me just show it to you in terms of an example, if this node out here wants to communicate with this node, so it will pass its data to the central device, and through the central device it will go over to this device here. Okay, so if something goes wrong with the central device, this entire topology will collapse. But otherwise, if something is wrong with the link, then in that case only this particular device would be affected. You understand that? So bottom line is, it provides you with a single point of failure, wherein if this central device goes bad, the entire topology will collapse. Okay. Now you can also have an extended star topology, wherein what we have is, we have this central device, but along with that they are extended further by putting up these kind of central devices, and from these central devices there are other devices which are connected to each other. So in that case, advantage is, even if the central device fails, okay, let me just show that to you in terms of the drawing. So even if the central device fails, the entire topology is not going to collapse. It is going to form these smaller units out here. Okay, so this would be one smaller unit, this would be another smaller unit, this would be another smaller unit, and this would be another smaller unit. So these smaller units are going to talk to each other, but as such the entire topology is not going to collapse. You understand? Similarly, if I talk about, let's say, okay, let's say I talk about this example wherein this central device goes bad. So that is the case, this entire section is going to collapse. The entire topology is not going to fail. The rest of the devices are able to talk to each other. Okay, so it is much more resilient as compared to the star topology. That is the advantage of using extended star topology. You understand that? Okay, so practically if you look at it, this would be again another common implementation of setting up a network. Okay. Now you can also have a full mesh topology, wherein all the devices are able to talk to every other device in the network. Like as you see here, this node out here is able to connect to or communicate with all the other nodes that are available in this topology here. Okay, so it is highly fault tolerant. Why? Because even if one of the link fails, the devices can talk to each other via another link or another path. Okay, but the only problem of full mesh topology is, it is very much expensive. It's very expensive to implement a full mesh topology, because if I talk about computers, if a computer needs to communicate with all the other computers directly, in that case I need to have those many number of network interface cards on a computer, right? So only when I have those many network interface cards, they would be able to communicate or talk to each other. Okay, so that is how I would put up a full mesh topology. So that's why it becomes expensive to implement. But advantage of using full mesh topology is, it is highly fault tolerant. That is, the network is never going to fail. Okay, so that's the main thing about it. If I talk about partial mesh is somewhat similar to the full mesh, but then in the case of partial mesh, all the devices are not directly connected to every other device. Some of the devices are connected to each other, but others are not. Like for example, this device out here is only connected to this device and this device. Okay, but this device out here is connected to all the other devices. So some of the devices are fully connected to everyone else, but every device is not connected in that manner. Okay, so it is a compromise between fault tolerance and cost. Okay, so it is cost effective. Let's put it that way. So it gives you a kind of redundancy or a bit of redundancy, but it does not give you high fault tolerance like the previous example. It gives you less fault tolerance, but it's still considerably fault tolerant. Okay, so that's the main thing about it. So that was this first section talking about the network. It also talked about the various components that can be used for setting up a network. We also talked about the major categories of the physical components like the computer, interconnections, that is the network media or the cable, switches and the routers. Okay. Now the networks can be typically depicted or put up or represented using standard icons, like you can have a separate icon for a computer, you can have a separate icon for a router, you can have a separate icon for a switch, you can have a separate icon that is used for a network cable, you may have a separate connection for a serial, you may have a separate connection or icon for a cloud or an internet, so that is what is used for representing network diagram. Okay. Now typically when I talk about major resources, okay, you can have data and applications, peripheral devices like printers or network storage devices or backup devices. Okay, so when we talk about common network user application, you can have email clients, or you can have web browsers, instant messaging applications, collaboration applications, or database applications. Okay, so depending upon those applications, they can be classified into real-time application or interactive applications. Okay, so depending on that, it will have a good effect on the network. Okay, and it will consume network resources. You understand? Okay, so whenever I talk about characteristics of a network, you would typically have the speed, cost, security, availability, scalability, reliability, and the topology. Okay. Now network topology can be represented as physical topology or the logical topology. Physical topology talks about how the devices are connected to each other in terms of wiring and so on, whereas the logical topology only talks about how the devices are going to communicate with each other or how the information is going to flow through. Okay. So with regards to that, whenever I talk about physical topology, you have the bus topology, star topology, extended star topology. Okay, so these are the different types of topologies that you can have, and then you can have fault tolerant topologies like full mesh or partial mesh. Okay, so that is what we talked about in this particular section. So do you have any questions with regards to what we covered in this first section? Okay, so at this point we have covered the first part of this particular section. Let's move on to the next part. Okay, so in the next part we are going to understand the host-to-host communications model. Okay, so what it basically, bottom line is, what we are going to talk about here is how two hosts means two devices, how are they going to communicate with each other. Okay, so here we are not talking about the cable connection or the devices that I use, but basically what we are going to discuss about is how communication takes place between two different devices. Okay, so that's what we are going to discuss about in this particular section. Okay, so when it comes to understanding the host-to-host communication, for better understanding, there are different models that are created, or there are different models that are available out here. One is the older model that was available, that was proprietary. That is, depending upon the vendor or depending upon the type of devices that were used, okay, they had their own proprietary way of communicating with each other. So in that case, depending upon the application and the combination software that was used, it controlled the application or it controlled the behavior in which these devices used to communicate with each other, and that behavior was totally controlled by the vendor. Okay, so bottom line is, if you bought devices or purchased devices from vendor A, then in that case the entire communication standard was controlled by that vendor itself. Okay, so that is how it was based upon the older model. But nowadays what you find is it is typically based upon standards. Okay, so the entire communication process is based upon standards. Okay, so when I talk about standards, the advantage of using standards is it has support for multi-vendor software and it is dependent upon a layered approach. Bottom line is, you can have multiple vendors and still it will follow the same standards. That's the main thing, and it also follows a layered approach wherein the entire communication is broken down into different layers, and those layers is what we are going to discuss as we go along in this particular section here. Okay. So whenever I talk about layers, okay, the common layer that we need to really talk about is the OSI layer. Okay, so let me just write it down out here. OSI. Okay, so that's the layer that we need to talk about. OSI is nothing but Open System Interconnection. Okay, Open Systems Interconnection. Now, since I talked about the model being standardized, okay, OSI came into existence. Okay, that is more of like an open standard. What it basically did was it reduced the complexity of understanding the communication. It standardized the interfaces. Okay, facilitates modular engineering. That is, you can engineer the communication process with regards to individual layers. Okay, it ensures interoperable technology. That is, you can put up technology or you can invent new sort of technology based on these layers. It accelerates evolution. It allows you to build upon the technology, and it also simplifies the teaching or learning of the communication model. Okay, so that's the main thing about it. So remember, the latest model, communication model that is available according to open standards is Open Systems Interconnection. Okay, so OSI as it is called. Okay, so saying that these are the 7 layers which the Open Systems Interconnection talks about. Okay, it starts off with layer 7, that is application layer. Then we have presentation layer, session layer, layer 4 is transport, layer 3 is network, layer 2 is data link, and layer 1 is physical. Okay, so these are the 7 layers that we typically have. Now going along, let's talk about each and every individual layer separately so that we understand it better. Okay, the physical layer typically used for binary transmission. Okay, binary transmission as in this is the layer where all the electrical signals are being sent out or electrical signaling standards have been defined. Bottom line is, okay, just give me a moment. Yeah, sorry about that. So when I talk about the physical layer, okay, when I want to pass some information over the wire, ultimately it's going to be electrical signals, right? That is what is passed across the wire. So those standards are defined in the physical layer. Okay, so binary transmission of information is what is defined out here. So it defines the electrical, mechanical, and the functional specifications for activating, maintaining, and deactivating a physical link. Okay, so when I talk about the network cable that is used or the network media, the media standards, all those kind of things are defined at the physical layer. Okay. The data link layer, when I talk about it, this is where it allows you access to the network media. What I mean by that is, whenever I talk about information, information is in soft format or it's not something in hardware, right? But ultimately I want to link that software or I want to pass that software through the network interface card. Now that network interface card is nothing but a hardware. So that interfacing of software and hardware happens at the data link layer. Okay, so the data link layer defines how data should be formatted so that it can be transmitted and how access to the network is controlled. So it also provides you with another feature known as error detection. Now what this error detection talks about is, if at all I am passing some information and if there are some errors, how would the devices detect those errors? Okay, so error detection is typically what is carried out at the data link layer. Layer 3, when I talk about it, is called as the network layer. The network layer deals with the data delivery. That is, it talks about or it defines what would be the destination of a particular information. So it basically allows you to route data packets, or it allows you to define what would be the path taken for a traffic to travel to the destination. Okay, so it selects the best path to deliver the data, and it provides logical addressing and path selection. That is the purpose of the network layer. Then we have layer 4, that is the transport layer. Okay, it deals with end-to-end connection. End-to-end connection means For communication to happen, you need to have minimum 2 nodes, right? That is what you need. So if the 2 nodes are the ones that are establishing a connection, so the end-to-end connection or the establishing of the connection or establishing of the communication between 2 nodes is defined as the transport layer. So it handles transportation issues between hosts. Okay, so that's the primary purpose of the transport layer. It ensures data transport in a reliable or unreliable fashion. It establishes, maintains, and terminates the communication between 2 nodes. Provides reliability through fault detection and recovery of information flow control. So bottom line is it does error detection as well as correction of data. Okay, if at all it occurs between 2 nodes. So that's the purpose of layer 4. That's the transport layer. Then we have layer 5. Okay, layer 5 deals with inter-host communication. That is, it establishes, manages, and terminates sessions between applications. Okay, so bottom line is even before 2 machines or 2 devices start exchanging information, they have to establish a session or they have to establish a communication between them. That is what is handled by layer 5. That's the session layer. Now, how the data or information needs to be presented, that is what is represented by the presentation layer. So bottom line is, if I talk about an image is represented in a different fashion, right? Similarly, if I talk about a PDF document is represented by the PDF extension. Okay, when I talk about a Word document, it is represented by a different extension. So bottom line is different types of data are represented in a different manner so that end users, whoever are using that data, are easily able to understand what kind of a data it is, right? Even encryption, when I talk about it, encryption is nothing but making the data unintelligible or making a data unreadable so that anyone looking at it will not understand what that is. So bottom line is you're presenting the data in a particular format, okay, so that it's understood by the relevant application. Okay, so that is what is the purpose of layer 6 or the presentation layer. And then we have layer 7, that is nothing but the application layer. What is the purpose of the application layer? It processes the various kinds of information. So what it basically does is it provides you with network services, okay, such as email, file transfer, terminal emulation. It provides you with user authentication. So bottom line is the application layer allows you the various or provides you with the various interfaces through which end users can communicate or end users can interact with the network. Okay, so that's the primary purpose of the application layer. Now, when I talk about the OSI model typically is a very old model that is available for understanding host-to-host communication. But a newer way, when I talk about it, or a newer model that is available is nothing but the TCP/IP model or the TCP/IP stack. Whenever I talk about the TCP/IP stack, okay, the TCP/IP model talks about 4 different layers. That is layer 1, that is the physical layer, is called as network access. Okay. Then layer 3, that is internet layer. Okay, like layer 3, that is called as the network layer in the OSI model. It's called as internet layer out here. Layer 4, that is transport. It remains the same, but layer 5, 6, and 7 are combined together, and it's called as application. Okay, so let me just write it down on the screen out here so that you understand it better. So if I talk about that, application layer is basically a combination of application, presentation, and session layer of the OSI model. Okay, so that is what is our application layer. Transport layer remains the same. Okay, it's not going to change. Then internet layer is nothing but the network layer of the OSI model. And then you have network access, which is nothing but a combination of data link and physical. So bottom line is the OSI model, when I talk about it, is converted into the TCP/IP model, which is only having 4 layers inside it. Okay, and the comparison between the OSI and the TCP/IP model is what I showed you out here. Okay, so the application, presentation, and session are combined together to form the application layer. Transport remains the same. Network layer is named as internet layer, and then you have data link and physical, which are combined together to form the network access layer. Okay. So that is what you see out here. Okay, so data link and physical together form the network access layer. Network layer is the internet layer. Transport layer remains the same, and then you have the application, presentation, and session, which are combined together to form the application layer. Okay. Now the next thing that we need to understand is whenever we talk about network data or data that is created. Okay, so let's say any data that is generated inside a computer, it is going to pass through all these individual layers, and then it's going to form information. Okay, so let's talk about what happens to that data. That user data, when it's passing through layer 7, it is going to add the layer 7 header to it. Okay, and then it's going to add layer 6 header, that's the presentation, then layer 5, layer 4, layer 3, layer 2, and ultimately this entire information is converted into bits, and that is what is passed through the physical layer. Okay, so this process wherein the raw user data is processed or added with various header information is called as data encapsulation. Okay, so that is what we do out here. We encapsulate the data with header information from each and every individual layer. Okay, so that is what is called as the data encapsulation. Okay, so this is while sending the data, but at the other end, on the other computer, when we are receiving the data, those the exact reverse process would be carried out. That is, at the receiver end, the bits would be then converted into the various user data and the headers, and then while it's passing through each and every layer, it's going to remove each and every header. While it's removing the header, it's going to understand what that information is about. Okay, so certain information about that data is stored in the individual headers, and those individual headers are processed individually at the individual layers, and then ultimately you get back the original user data. Okay, so this process is called as data de-encapsulation. Okay, so understood. So when I'm sending data, data is encapsulated, wherein header values are added. Okay, what is this FCS? Okay, the FCS that you see here is nothing but Frankwell Consultancy Services. I'm just joking out here. Okay, well, FCS is nothing but frame check sequence. Okay, so let me just write it down out here. FCS is nothing but frame check sequence. Now, what is this frame check sequence? Okay, earlier when we talked about the data link layer in the OSI model, I told you that the data link layer also does error detection, right? So that error detection information is stored in the frame check sequence. You understand that? Okay, so it is also called as a trailer. Just like we have a header to a data, we can also have a trailer. So the trailer will typically contain the frame check sequence. You understand that? Okay. So that's the main thing about it. So FCS is nothing but frame check sequence, and that is added at the data link layer. Okay. So bottom line is any sort of errors that is detected on the data, it would be stored in the frame check sequence. Yeah. So talking about the peer-to-peer communication, okay. So that's the sender and that's the receiver. But between them, data is going to pass through each and every individual layer, right? So through the physical layer, it's going to be called as bits. But the information that is created at the data link layer, they are called as frames. The information that is created at the network layer or layer 3 is called as packets, and the information that is created at the layer 4 or the transport layer is called as segments, and the information that is there at the other 3 layers, that is application, presentation, and session, they are called as PDUs. Okay, so let me just write it down out here. Okay, so they can be called as data. Okay, just regular data. Okay, so at these individual layers, application, presentation, and session, those same things can be called as data, or sometimes they are also referred to as PDUs. Okay, that is protocol data units. Okay, so sometimes this data can also be called as PDUs or protocol data units. You understand that? Okay, so remember at individual layers the data or information can be called as something else. Okay, what I mean by that is at the physical layer this information is called as bits. At the data link layer they are called as frames. Network layer it's called as packets. Transport layer is called as segments, and session, presentation, and application layer is called as data or PDU. Okay. So that was this section talking about the OSL layer and the TCP/IP layer. Okay, so let me ask you some questions based on whatever we just learned. Okay, do you know what is the information at the data link layer called? Okay, you can reply back in the chat window. What is the information at the data link layer called? Okay, let me repeat my question. What is the information at the data link layer called? Do you know? Well, typically the information at the data link layer is called as frames. Okay, so that is what I just mentioned, right? So the information at the data link layer is called as frames. You understand? Okay. What is the information at the transport layer called as? Do you know? Information at the transport layer, what is it called as? No, the information at the transport layer is called as segment. Okay, data is typically the information at application, presentation, and session. Remember that. Okay, so don't mix it up, because even with regards to the exam or even in interview, it is like a relevant question. Okay, so remember that at each and every different layer it is called something else. So let me just quickly revise that with you. Okay, at the physical layer information is called as bits. Okay, let me just write it down out here. So at the physical layer, okay, information would be called as bits. At the data link layer, okay, information would be called as frames. Okay, so information would be called as frame. Then at the network layer, okay, the information would be called as packets. At the transport layer, okay, it would be called as segment. And then at the application, presentation, and session layer, it's called as data, or it can also be called as PDU or protocol data units. Okay, so are we clear about all these terms out here? Okay, so remember it's a important exam question as well as a question that that you might face in interviews as well. Okay, so are you clear about these terms here? Okay. So that was this section talking about the OSI model and the TCP/IP model. Let's move on to the next section. Okay. Do you have any questions of whatever we covered until now? Okay, these are basic stuff, but it's really important when it comes to understanding networking. So, do you have any questions with what we covered right now? Okay, okay. Let's go ahead then. Okay. So, getting along. Now, what we are going to talk about is we are going to understand this term known as a LAN or local area network. Okay, so we are going to have an introduction towards local area network. Okay, so that's what we are going to talk about right now. So whenever I talk about a local area network is nothing but a network that is limited to a single building or a single geographical location. Okay, a computer network that is limited to a single geographical location is called as a LAN. You understand? Okay, so let me repeat that again for you. A LAN is nothing but a network that is limited to a single geographical location. You understand? Like what I mean by single geographical location is it can be a single building or it may be a particular floor. Okay, so bottom line is if I have a network established within a building within a single geographical location, it would be called as a LAN. So with regards to that, you can have a large office LAN or you may have a small office LAN. But a LAN is nothing but a network that is created or that is set up within a single geographical location. Okay. So let's talk about what are the components that make up a LAN. Whenever I talk about LAN components, you would need computers. Now these computers can be PCs, that is desktop computers or laptops. It can be servers. Okay, that would be another machine again. Then you would need interconnections, that is network interface cards or NICs, and then you would also need media. Now why would I generally put it up as media but not as network cable? That's because the network connection can be wired or wireless networks as well, but in that case you would need these kind of interconnection options. Then you would also need networking devices like hubs, switches and routers. Okay. Now let's first talk about hubs and switches. Now I'm not going to get into details about hubs and switches immediately, but then hubs and switches allow you to interconnect various networking devices. Okay, so what is the purpose of a hub and a switch? A hub and a switch are typically used to connect various networking devices. Okay, whereas when I talk about a router is used to connect different IP networks. Okay, so the thing that is different between hubs and switches and routers is hubs and switches are typically used to interconnect various networking devices, whereas routers are typically used to connect different IP networks. Okay, so routers are used to connect different networks, whereas hubs and switches are used to connect different devices. Okay, so that's a major difference between the two. But you would need these kind of networking devices, and then you would need protocols. Okay, so let's try to now understand this term protocol. What is a protocol? Okay, so protocol is nothing but a set of rules that is used for communication. Okay, so what is a protocol? A protocol is a set of rules that is used for communication. Okay, now why am I elaborating on these terms? Okay, it's because like towards the end of the course, that is when you're getting certified on CCNAX, okay, you would be appearing a large number of interviews, right? So these are all common interview questions which you would come across. So it's all the more important that you remember all these answers. Okay, so I don't mean to say that you go word by word with regards to definition, but at least I need you to understand what these individual terms mean. Okay. So when I talk about a protocol, it is a set of rules for communication between network devices. Okay. So when I talk about that, we have Ethernet protocols, IP, that is Internet Protocol, ARP, that is Address Resolution Protocol, and then we have DHCP, that is Dynamic Host Configuration Protocol. We'll be talking about all these protocols as we go along in this particular course, but for setting up a LAN, you would need all these components. Okay. Now, with regards to that, okay, whenever I talk about a hub or a switch, okay, typically I may have all these computers or all these devices connected to each other via the hub or the switch. Now, sometimes it might happen that, okay, let's say we take an example wherein we have these devices and both of these devices are simultaneously sending in data to each other. Okay, if they are trying to send data across to each other, it might happen that both the data would collide with each other. Okay, so that collide when the data collides with each other, that is where I would have collisions. You understand? Okay, so what is a collision? Okay, a collision would typically occur when two devices try to send data across to each other simultaneously. Okay, so when two devices try to send across data to each other simultaneously, that's where it would form a collision. Okay, now what is the disadvantage of a collision? Whenever there is a collision that occurs, it would mean that the devices would not be able to communicate anywhere. Okay, you would find that the network is going slow. So bottom line is a collision on the network is not good. Okay, it is going to bring about disruption of communication, or communication across the network is going to stop when you make use of collision or when you encounter network collision. Do you understand that? Like in this example, this symbol that you see here is that of a hub. Now, when you are making use of a hub, what you will typically find is all data is shared, or the entire device is shared. The hub is shared with all the devices. So bottom line is, if at all I have two devices sending data across to each other simultaneously, there would be a lot of collision that is encountered. Okay. But whenever I talk about a switch, okay, the advantage of using a switch on top of a hub is, well, of course, one of the main things that you need to look at is the symbol that is used for a switch. In the case of a hub, the symbol that is used is a bidirectional arrow, okay, just a single arrow. But when I talk about a switch, it will have these kind of 4 arrows out here, okay. But when I talk about a switch, it will maintain its own collision domain. What I mean by that is each and every port will have its own collision domain. Okay, so bottom line is it is not going to form any collision. It is not going to share the data across. So bottom line is, if at all I have a 10 port switch, for example, okay, you would never find a 10 port switch. You might find 8 port, 16 port, 64 port, and so on. But let's say if I have a 10 port switch, which means that switch is going to form 10 collision domains. Remember that. Okay, so if a switch is of 10 ports, which means it's going to form 10 collision domains. So bottom line is, okay, the switch is going to maintain the same kind of bandwidth across all the ports. So that's the reason it's going to form its own collision domain. Okay, so bottom line is, if at all this machine encounters a collision, the others are not going to know about it. But in the case of a hub, if this machine or these two devices encounter collision, every device that is connected to the hub would know about the collision, and effectively the network performance is going to reduce. But in this case, in this example, what is going to happen is, if there is a collision that is encountered, only the devices would know about it. Other devices would not even understand that there is a collision that has occurred on the network. Okay, so they are not affected, or in turn the network is not affected when we make use of a switch. So as such, a switch is recommended as compared to a hub. And if you look at the scenario nowadays, it is very difficult for us to find hubs. Okay, nowadays everyone makes use of a switch. Okay, if you want to make use of connectivity option, the only device that is available for interconnection is a switch. You understand? You would not find hubs. Now, an older method or older kind of a switch was also called as bridge. Okay, so before the evolution of the switch, we had devices called as bridge. Okay, will it divide a bandwidth of 100 into 20 people, 20 for 5 people? No. When I talk about a switch is going to provide the same amount of bandwidth across all the ports. What I mean by that is, the switch is going to provide 100 Mbps. Okay, even if it is 5 people or 10 people, each of those 10 people are going to receive 100 Mbps bandwidth. But if it is a hub, yes, then in that case, whatever question you have asked will make sense. That is, in the case of a hub, it's going to share the bandwidth. Okay, that means if I have 5 people connected or 5 devices connected, each device is going to get 20 Mbps of the bandwidth. Okay, so in a hub, we'll have bandwidth sharing, but in a switch, it's not going to share the bandwidth. It's going to equally provide the same bandwidth across all the ports. You understand that? Okay, so as I was talking about bridges, the major difference between a bridge and a switch is a bridge only has 2 ports. Okay, and when I talk about a switch has multiple ports and it is faster as compared to a bridge. That's the main thing about it. Okay, do you understand that? Now, whenever I talk about a hub works on the physical layer. Okay, the hub as a device works on the physical layer, that is layer 1. Whereas when I talk about a switch or a bridge, okay, a switch or a bridge works on layer 2. Remember that. Okay, so since it is working on layer 2, the switch will forward, filter, or flood frames. If you remember, the information that is passed on layer 2 is nothing but frames. Okay, so that is what it's going to do. It's going to forward, filter, or flood frames. Okay, so that's the main thing about switches. Now, if I compare switches and bridges, both of them are going to work on layer 2 and they are going to forward frames. But then the major thing about bridges is bridges only has 2 ports, whereas switches have multiple ports and they are faster as compared to a bridge. Do you understand that? Okay, do you have any questions with regards to switches? So that's the reason nowadays you find switches that are used. Okay. So nowadays on a LAN, when I talk about it, you'd find all the devices are connected to each other via switches. Okay. So in that case, the users are grouped based on physical location. More switches are added to the networks, and switches are connected to each other by high-speed links. Okay, so that is what you would typically find. All these groups are individually connected to switches, and these switches in turn are connected to each other via high-speed links. Okay, so that is what you would find typically on a LAN nowadays. Do you understand that? Now, let's talk about LAN switch features. Okay, so whenever I talk about LAN switch or a switch in general, it's going to provide dedicated communication between devices. Okay, now this is nothing but elaborating on the collision domain that I mentioned before. Each port maintains its own collision domain, right? That's what I mentioned before, right? Due to which now, okay, each device or each port is going to maintain its own communication. So bottom line is, communication that is happening on a particular port is not known to any other port on the switch. Okay, so if 2 devices are communicating with each other devices that are connected to that switch will not know anything about that communication. Okay, so that's why it provides you with dedicated communication. And another major advantage is you can have multiple simultaneous communications happening. That is, you can have multiple groups of computers talking to each other on the same switch. It provides you with full duplex communication. What do I mean by full duplex communication? Full duplex communication means I can send as well as receive information. A half duplex communication means I can either send or receive, but full duplex means I can send as well as receive information. Okay, so that's the main thing about full duplex communication. So that is possible if you make use of a switch, and it is also going to adapt to the various media rates. That is, if at all you have a computer which is running an older form of a network adapter, an older form of a network adapter may only give you speed of up to 10 Mbps. So if you connect that computer onto a switch port, okay, then in that case the effective speed would be 10 Mbps. But in that same case, if the switch supports 100 Mbps, okay, and the computer supports, let's say, 100 Mbps again, in that case they are going to negotiate 100 Mbps. Okay, now let's take an example wherein the switch supports 1 gigabit, okay, 1 Gbps, and the computer supports 100 Mbps. Then in that case the switch effectively is going to provide 100 Mbps. But then if at all you have a computer which has a 1 gigabit Ethernet adapter, 1 gigabit Ethernet adapter means 1 Gbps speed. Okay, the network card of the computer supports 1 Gbps, and then the switch also supports 1 Gbps. Then in that case, the bandwidth on that particular port would be 1 Gbps. Okay, so it will adapt itself automatically depending upon the type of devices that you have connected onto the switch port. Okay, so these are the various switch features that are available. Okay, so talking about a LAN switch, now the switch diagram that you see here, or the photograph of a switch that you see here in the diagram out here, is nothing but a Catalyst 6500 series switch, which looks like a mini refrigerator. Okay, but then the main thing about these switches is it has a many number of ports on it. Okay, so you have a high port density, which means a high number of ports on this particular switch. Okay, it also provides you with large frame buffers. What I mean by that is it allows you to transfer or transmit huge size buffers, huge size frames. Okay, it allows you to transmit frames which are big in size. It also allows you for a mixture of port speeds, that is, some ports working on 100 Mbps, some ports working on 1 Mbps, another ports working on 10 Gbps, another ports working on 1 Gbps. Okay, so it can give you a mixture of all these port speeds. It allows you fast internal switching, that is, communication between the ports is faster when it comes to switches. And whenever I talk about switch operational mode, they either work in buffer is nothing but a memory allocation. Okay, every device has a fixed amount of memory, and whenever we talk about data or information entering into the switch, it's going to pass that information across into the buffer, that is that memory allocation, and then it's going to process that data. Okay, so buffer in turn is nothing but memory allocation. Okay, so that's the reason you would typically find RAM on each and every device. What is the purpose of this RAM? The RAM is providing you with the buffer. It is on the RAM where the data would be stored and processed. Okay, because whenever it comes to processing data, the device can process only a certain amount of data. Okay, but the information that may be coming in into the device may be greater than the amount of data that the device can process. Yes, it is basically like a queue. Okay, so the excess data would be put up into the queue. Okay, and then the processing of the data will happen in the RAM. Okay, so that's the way it is going to work. So the excess data that is stored while it's being processed is called as the buffer. You understand? So saying that a switch would typically work in cut through mode. Okay, cut through means as and when the data is coming in, it would be processed and forward, or it can work in store and forward. Store and forward means whatever information comes in, it's going to be stored, processed, and then forwarded. And then fragment free means whatever frame comes in, it's never going to be fragmented. Now what do I mean by fragmented? Fragmented means the frame is not going to be broken down into smaller pieces. The frame is going to be processed as it is. Whatever be the size of the frame, it's going to be processed as it is. Okay, so that's the main thing about fragment free. Okay, so it's going to process it as the size it comes in, and then it's going to be forwarded accordingly. Okay, so that's what I mean by fragment free. And by default, a switch works on the concept of store and forward. Sorry, it works on the concept of cut through. That is, as and when the frame comes in, it's going to be immediately processed and forwarded. Okay, so by default, the frame or the switch is going to operate on cut through. Okay, remember that. So that was this topic talking about a LAN. Okay, but then when I talk about a LAN, remember this: there is no particular size for a LAN. Okay, the LAN is defined by the network, which is limited to a geographical location. So any network limited to by a geographical location like office building or a particular floor or a particular office, that is what is called as a LAN. Okay. Now, saying that, whenever I talk about setting up of a LAN, you would need a lot of different components like PCs, you would need network media, you would need interconnecting devices like routers, switches, or hubs. You would also need applications or protocols. Okay, so we also talked about the various Ethernet switches. They allow you to exchange frames between the devices. Okay, so they selectively forward individual frames from a receiving port to the destination port. Now, one of the main things about switches is it has a high port density. That is, it can have a lot of ports in it, and each of those ports can work on a different speed altogether. Okay, and they do not share the bandwidth. Okay, so that's the main thing about this particular section out here. Okay, so do you have any questions with regards to this section here? Okay, great. Now, the next section that we have is about operating the Cisco iOS software. Okay, now for that, I would need you to have a packet tracer also on your computer. Okay, so what we would do is we would stop our session out here for today, and tomorrow we are going to start off with this particular section here, wherein we'll start working on packet tracer or we'll start working on the Cisco switches, because now we are going to understand about Cisco iOS software. So it would be good if you have packet tracer along with you, and you would run packet tracer like along with the demonstration that I'm running, so that you also understand it better. Okay, so that's how we are going to do it. Okay, so we'll stop our session right now, and then we'll cover back the remaining part starting from here tomorrow. Is that all right? Okay, so do you have any questions with regards to whatever we covered today? Okay, if that is the case, we'll stop the session and we'll meet back tomorrow. Okay.